So I would like to present a WebLab project, and especially open access, which is a WebLab sub-project. So first of all, who am I? So I'm Yann Mombrun from Airbus Defence and Space, formerly known as Cassidian. I've seen it in some slides this morning. So Cassidian has been merged with Astrium, which was a space subsidiary of EADS, and now we are one of the subsidiary of the Airbus groups, so ex-EADS. I'm in a team of 10 engineers and PhD students, now located in Elancourt. We were before in Val-de-Reuil, Normandy. And we are working on R&T and R&D projects for unstructured document analysis and data fusion. So what's unstructured document analysis? So we start from unstructured data, whether coming from the internet, from social networks, or from internal databases. And we try to analyze this in order to produce structured and actionable knowledge or intelligence. So to do that, we need a lot of tools that have to be organized together to work into complex processing chains. So starting from data gathering, so accessing the data on the internet, on networks, on local networks, social networks. The normalization, so extracting text from documents, converting the videos and the audio to have into codecs that are handled by the next services. So doing some automated translation if needed, extract information, whether from text like name entity recognition or object detection inside images, speaker identification inside audio, whatever. And merge, fuse all that information that is extracted from the documents, and at the end index the data into structured databases to enable search, whether text search, geographical search, and whatever is possible. So it means we need to have an integration platform because of the complexity of this chain and the variability of the data, because there are a lot of formats, a lot of media, so audio, video, and dark text, and also a lot of language that have to be handled, and some components that we are using are, for instance, only working on English, while another one is working on French and German, or whatever. So we need to combine those components. So that's why we have designed the WebLab, which is an OW2 project, which is our integration platform used inside Airbus Defence and Space. It allows integration and the selection of softwares, and to combine them, because each of the softwares that you can find on the market or on open source does not handle the whole processing chain which is needed. It does not make the data acquisition, translation, information extraction, and visualization at the end. You often need to use and to pick specific tools for each kind of your needs. So we need to enable the interoperation of the selected tools. So we are relying on open source standards. So for the service-oriented architecture, web services, and semantic web for the knowledge, and enabling the composition of services inside the chain. So WebLab is both an integration platform and, in fact, a set of media mining services for document processing that we are reusing in all our WebLab projects. Some of them are open source and provided on the OW2, whether on the WebLab project or on the open access project, and some others stay closed source at Airbus. So WebLabs is also a range of projects in a set of media mining tools. So we started in 2004 for initial studies. Then we worked based on co-funding and cooperating projects using from ANR, so French National Research, and the European Commission on web content. So it was an ANR project which aims at providing an infrastructure for document analysis. So it was basically the same idea of WebLab. So during this project, we worked with the CEA, and together we, 2 years later, provided released the WebLab on OW2, integrated OW2 thanks to other projects like Virtuoso, SIMC, and the one that I will focus next, which is Axis, which aims at extracting information inside audiovisual databases. And I'm now working on the SIP project, which is kind of follow-up of Axis, but she's working only on audio so SIP is a speaker identification integrated project. So Axis project finished in 2014, so there is still a website. The administrative coordination was done by RCM in Nice. The technical partners were the University of Leuven for image classification, image identification, object extraction, place detection inside image. And they were the technical coordinator of the project. For image analysis, there was also Oxford University, INRIA Lille in Grenoble, and Technicolor. For audio analysis, it was Fraunhofer. The GUI was done by DCU, Tech Search by Twente and Twente University in Holland, and we were doing with Airbus the integration platform and filling some gaps inside the whole processing chains when it was needed. Our content provider and end user were the BBC Research, Baden Gullion, which is the archives of Netherlands, so like INA in France, Deutsche Welle, which is a broadcaster, German broadcaster, and so these three end users were also content providers, and Erasmus University was the kind of end user, so it's people from the humanities, which were using databases to produce articles. So, what was the aim of Axis? It was we were planning to develop tools to provide new ways to interact with the database and not only search inside, but also be able to browse, to explore the database, and to experience it in order to ease the knowledge, ease the production of knowledge based on the databases. For plenty of users, so various kind of users, media professionals, so Deutsche Welle, we had journalists who aims at producing article reports based on the database of previous reports that have been done, researchers from Erasmus, home user, so anyone who wants to use the system, and intelligence officer, so it was for us. To do that, our technical partners, so mainly Oxford and for computer vision and KUL, so KU11, we're using a lot of techniques of computer vision, speech recognition and audio analysis from Fraunhofer, search and navigation from DCU and Twente. The idea was to enable the the extraction and recognition of people, places, events, and object category based on multimodal analysis. So I mean that in the system we were extracting and trying to identify people based on the photo, but also based on the speech. And then a system does a fusion based on the assumption that it was that the same people who was speaking and who was on the screen. And the same thing for places and things like that. So, what the final architecture of the Axis project? So it starts from video content. The video content, which were provided by content provider, were located in structured and very particular databases. So we had to develop some component to be able to retrieve that data. So whether it was, in fact, very simple on our drive, but also it might be inside specific databases. Then we had to do a lot of processing, as I said. So to do that, we focused on the WebLab for the orchestration and for the interaction between all services. Then the data which has been normalized and extracted and a part of analyze was indexed inside specific image databases. and text databases. Twinter was working on the linking, so the linking was not only the search, but also the recommendation of similar content and things like that, based both on what you are browsing and on the content that you are looking. Since we are many kind of user, we have developed various systems with different UI because the needs of the user were not the same. For instance, the Axis Pro system, which was the first one developed during the project, was focusing on the archivist from National Institute of Sound and Vision and of BBC, whose main work is in fact to watch a video, store it in a database, and annotate it to tell what was inside, so that later on, other people can browse and find that video. So for the moment, it was done manually. I mean, when a TV show is presented on BBC, the transcript are put inside, but people are also writing down who was inside, who was the actors, what was their role. But some of the things, like the people identification, might be done almost automatically, at least for helping the people. So at the end of Axis Pro UI, we had a system that was pre-computing the list of people inside the video, so that the annotator might save some time. Instead of having to write everything he sees, something was already written. So he had probably to remove some errors. He still has to add some data, but some part of the information was already filled. Then we have developed the Axis UI, home UI, so for the home user. So the idea was to have something much more like YouTube, where people are spending time, and you watch a video and you will have recommendation of similar videos so that you can spend a lot of time on the system. And the research UI, which was focusing on journalists who wants to produce reports. The Open Access project that I will present later is reusing the Axis Research UI, which was the one which is the most easy to understand. So what was the Open Access project? So Open Access project is the free or, I will explain why or after, open source version of Axis, which is a Node OW2 WebLab sub-project. It was proposed to European Commission and required by end user during the project because they wanted to be able to make some demonstration and maybe to buy some software later. And they wanted to be able to compare, we were just before talking about benchmark, but they wanted to compare from an end user point of view, the results of the system. I mean, comparing if one named entity extractor is better than another, if one image recognition system is better than another. So they wanted to be able to plug the system, to integrate another component inside, and to see if the results are better or not, but only from a user perspective. And the idea was also to have a baseline for a following project proposal. So what we have done is that we have been using partners code who wanted. We have replaced some of the components by similar components when it was not possible to use the code of the partners. And when I say it's not fully open source yet, it's because two components provided by partners wanted to have their components available in the demonstration, but were not able to release their code. So it's a binary system, so it's a freeware for two of the components. But the problem is, for us for the moment, is that one of the components from Technicolor is crucial for the system. So we're working on replacing it in the meanwhile, now that the project is finished. And for Airbus, it was a good idea to have an open access system because it's complementary with the WebLab demonstration, because this one will be focusing on multimedia processing. So what's inside open access? Video normalization, so you put your video inside. It's normalizing the video to convert it to a format which is handled by the next components. Then there is shot boundary detection provided by Technicolor and keyframe extraction. This is needed to prevent from analyzing all the images of a given video and to selecting only the keyframes of a video. Then we have image concept extraction provided by KU11. So the aim was to annotate each keyframe with one of the concepts that they have learned. They have learned 1,000 concepts over the ImageNet network. Then there is a spoken word and metadata search, speech to text. So previously it was done by Fraunhofer EAS, but it was not possible to use the software in this kind of demo, so we have replaced it by CMU Sphinx, which is an open source, and with the CMU models for English, and the LIUM, so it's Le Mans University for French models. Similar image search, so here again it was at the beginning provided by InRealIR, and it was not possible, because they are selling the software, basically. So we replaced it by Pastech, which is another open source. So on-the-fly search, provided by the University of Oxford. On-the-fly search was one of the main results of the Axis project in terms of research. The idea of the on-the-fly search is that you cannot always predefine the kind of objects, the kind of information that you want to extract and that you want to annotate inside a video. For instance, the KU11 system is relying on the 1,000 classes that are provided by the ImageNet. So there is 1,000 kind of information that is annotated. So it can be, there is a boat inside the video, there is a person, there is a hammer, there is a tiger, whatever. So there are 1,000 classes, but you always find a use case where another class was needed. So the idea of the on-the-fly search is that, in fact, it Googles the words that you are searching, it downloads the images that are responsive to Google, it learns a model from it, and annotates your database based on that learned on-the-fly model. And then, so favorite likes, most view was provided by DCU, and recommendation by UT. The system is compatible with Ubuntu and Mint, so it's Debian-based, basically.
What was the driving motivator from Airbus's perspective for doing this kind of collaboration, this kind of tool?
There is a lot of services, I mean intelligence services, that are very interesting in analyzing automatically what is inside a video provided on YouTube, for instance. So, and we are selling our stuff to intelligence services, basically. But also we are working on competitive intelligence, and that's also something which is very interesting, to be able to automatically know when your competitors are providing some videos on YouTube, some demo of their system, and to analyze it automatically. And we are also working on that competitive intelligence field. So that's the idea.
We can see also more and more embedded technologies for image recognition. Do you work on that aspect too, for embed the recognition of text and?
Yeah. In fact, inside access project, when it was only written here, image indexing and things like that. In fact, for instance, Leuven was working video OCR, so extracting the subtitles and any kind of text which was written, like demonstration text, like a slogan, motto, and things like that. And we were also working, I mean, our partners were working on the extraction of a lot of things that are working here. So there is a database of places provided by Oxford, which annotate the image and try to locate, not only based on the metadata of the image, but based on what is seen, so it was able to recognize well-known places like the Eiffel Tower and things like that, but also it was trying to, there was some effort on some typical city-like. I mean, it's a country, it's a city from the south of France, it's something from the south of Italy, for instance. It's really, really hard. Because there were a lot of similarity between the various kind of, but it was one of the work also.
Thank you very much, Yann. We can applause.
You're welcome.